Welcome back to Motorcycle Engineering and Design. In the previous video we looked at using surface forming to model the rear tailpiece. In this video we're going to take advantage of the quality of surface we can generate with surface forming, and then we're going to bring that into our parametric surface modeling. This will be more ideal for adding those extra design features. Then we'll go to rendering, apply our appearances, and then also experiment with adding decals. So in the previous video we saw how having too many control points may lead to kind of lumpy surfaces. So this time we can see how I've split the rear tailpiece into a number of different surfaces. The reason for this is so that we can simplify the curvature to ensure better surface quality. And we can always check the quality of the surface by inspecting the surface curvature using the zebra or the zebra analysis tool. Now, this kind of work would usually be done by the industrial design team. They would produce these very high quality surfaces, and then they would pass those on to the engineering design team to then produce the final parts. So here I'm going to take that kind of approach. I'm going to take these high quality formed surfaces and I'm going to start using them within our parametric modeling space. So I think we can already see how these surfaces are going to come together. We'll have to use some surface extends, trims and stitches to bring it all into one piece. There is some surfaces missing which we'll have to model in as we go along, as well as some extra details such as for the rear pillion seat or the seat cowl. Now I do have a visual reference which I've looked at before beginning the modeling, but just for inspiration, so I'm not referring to it throughout the process. But I did find something interesting, so I'd like to just talk about that for a moment. So it may already be obvious from some of the images throughout this video, but the bike that's been selected for reference is the CBR 600. Now I was originally thinking to model the tailpiece of each generation of models, starting from around the year 2000. The CBR 600's design has actually remained pretty consistent. There was one generation where there was some deviation, but it looked like they very quickly returned to their kind of trademark design. So to model each of these as a kind of exercise would kind of be meaningless because they're all so similar. It would just be an exercise in repetition in that case. So I take note of the design feature, which I will try to include in the design later on, but I don't do a good job remembering the orientation or the shape. In general though, for this design to have been so similar throughout the generations, I think it's a very nice, very clean design, and it doesn't need to be more than that. Now coming back to the model here, we basically finished trimming and stitching these surfaces together to make a single quilt. There are some extra details I'd like to add, starting with the recess for the seat to sit in, and I'll make that with a simple surface extrusion, and then we'll take that surface and we'll trim away the body of the tailpiece, and then we'll use the remaining body to trim the material away from this surface. And then we'll use that surface to kind of fill the space. Then we'll want to add a cutout for the underseat storage. Looking from the side, you can see that we've missed some surface geometry at the back here, so I'm just going to use some simple extrusions and just try to form a nice enough curve. So with this central surface, I want to create a plane along the path and disable the tangent chain, so that I can more easily select the end of this curve. And on this sketch surface I want to just draw some geometry which we're going to sweep along this edge. So we're going to try and keep it simple. So we can already see the surfaces are not going to be as nice as we'd like. So I'll come in here and I'll do some tweaking. After making the changes, we can start trimming and stitching these surfaces back together. Now we have some sharp edges here now, so I'm going to add some radiuses, and I'll start with this edge where we've merged in the new surface. And then we'll move on to this larger edge here, and we'll use a variable radius on this one. Essentially how this works is we can define a number of points along an edge, and then we can also set the radius at each specific point. Now here I just wanted to make a couple of last minute changes, cutting out some of the section at the front of the bodywork here. Then of course there are all the additional rounds to add just to finish off the shape. So something useful to know, we can go back to our form surface and modify that, and it will update in our parametric modeling where we've used this surface. Here we can also notice that the surface that was trimmed earlier has actually flipped. So now we have a floating surface where we should have a hole, and the bodywork surrounding that hole is no longer existing. So luckily, because we're in parametric modeling, we have a tree at the bottom, and we can go back to find where the trim is flipping. So at this point I decided to start adding in the design features. So like the CBR 600, we'll have a kind of vent hole either side of the tailpiece. So for this I've just created an offset plane from one of the origin planes, and that's just so that I can do a sketch whilst looking at the profile of the tailpiece. So a feature like this is going to look better if the profile matches the body. So after creating a projection of this edge, I then create an offset to use in my sketch profile. I'll then extrude this sketch through the tailpiece as a surface, and then trim this together to have a final quilt. And then usually we'll have a similar profile on the bottom of the fairing as we have on the top here. So in this case I'm just going to extrude this surface straight through and then trim the surfaces away on the underside. So now it's time to start applying some appearances to our models in the render mode. So here we can see that I've already downloaded a number of different materials into my library from the Fusion library. Now I've applied a fabric material here, which doesn't look so good, so I apply a leather one. And then I take the yellow plastic glossy and I apply that to the main body piece. As for these design features, I want them to be black, so I take this plastic matte black, and I need to change the setting to apply to faces instead of components and bodies. I can then hold Control as I select all of the surfaces and then just place the black material or black appearance just on one of those surfaces, and it will paste to all of them. And finally, to give it a more complete look, I will apply a decal, which will be in the form of a PNG. So I've taken these images off of Google and I've brought them into a software called Critter. It's very similar to Photoshop and it's free. Now I drew a box around the section of the sticker that I want to keep, and I use trim to select it. Then I can use the select similar color tool, and that will allow us to highlight all the white background, and then I can just hit delete to remove that. So once it's saved as a PNG, I can then bring it into the model as a decal. So after selecting the image that we want to use as a decal, we then have to select the surface that we want it to be applied to. We then have all these handles for the transformation, just to get it into the right place. Just a quick warning here, Fusion does not render decals if it's on a surface that's still a surface. It will only render these decals if it's pasted to a solid body. So I have actually thickened this quilt by just 1 millimeter or 2 just to make it a solid body. Again, I'd just like to say thank you to everyone that stuck around to the end to see the final result. If you have any requests for what you might want to see next, please feel free to leave them in the comment section down below. Otherwise, I'll see you next time.